Is like an operating system, but a special operating system which can virtualize your underlying hardware. Right? So there are a couple of CPUs. So what it does, it creates a pool of CPUs. It's a pool of CPUs, and it can allocate those CPUs to multiple VMs running in that or on that server. And there are two ways to do that allocation. The one is dedicated. So if it is dedicated allocation, so this, let's say I allocated 4 CPUs to this VM. So 4 virtual CPUs are allocated or reserved for this VM. So no one else can use those virtual CPUs. Remember, it's all virtual CPUs, not physical. So dedicated. Then there is another one called shared allocation of CPU. So let's say this machine now remaining, let's say this was a pool of 40 virtual CPUs. 4 were allocated to this VM in dedicated mode, remaining 36. Now these 36 can be shared, or this is allocated shared. So all of these VMs can now use 36 virtual CPUs in a shared mode. So at any point of time, let's say all 3 are running, so 12 each will be given to all. 12, 12, 12. But again, those are shared. So let's say at some point of time, this VM is using only 8 CPUs. So remaining 4 will be equally distributed, or whichever VM is needing more CPUs can be given to that VM in the shared mode. So shared means we have any of this VM will not have the control of those CPUs. They can be distributed, keep on shifting among the available or running. 2 VMs are down, or you shut down those 2 VMs, only one VM is running which is using shared CPU. So all 36 virtual CPUs are now available to this VM. So now can you tell me which mode is more useful, dedicated or shared? Shared, right? But if I increase the number of VMs, then the availability of the shared CPUs to each individual VM will go down. But in case of dedicated, because it is 4 CPUs dedicated to that VM, will always be 4 CPUs. So if I say that you have 2 types of jobs, one is critical, another one is non-critical. So what type of CPU allocation you do these 2 jobs? What type of CPU allocation to do this critical job? Dedicated to the critical and shared to the non-critical. It's always like that. Okay? So you always go for dedicated CPU allocation to all the critical jobs, and non-criticals will get shared CPU allocation. So remember that these virtual machines are capable of doing many things, or these hypervisors, with the help of these hypervisors, we can increase or create the virtual machines anytime. Any number of virtual machines can be created or can be destroyed without any loss of data, because your data will never be stored on this virtual machine. Your data is always stored at a central location. What is that central location? SAN. SAN is that central location, which is a storage area network. Storage area network is what? It's a collection of hundreds of storage devices connected together, and then the hypervisor servers can use those locations or those storage. Now, CPUs, you know now CPU can be shared. But what about the memory? So memory is always dedicated. Memory is not shared, or it's not equally not even equally distributed, depending on whatever you have allocated to a VM in your server, that will be reserved for that VM if the VM is running. Only if the VM is running, that will be reserved for that VM. So if I have let's say 100 gigabyte of memory, so 20 gigabyte let's say reserved for hypervisor, then 80 is remaining, which can be distributed to these VMs. So if I allocated 10 GB here, so 70 remaining, 20 GB here, 50 remaining, 30 GB here, 20 remaining. So it's all dedicated allocation. Memory will never be shared. Okay? Hard disk. Hard disk is always required for data and for operating system. So operating system files, all the operating system files are always stored on SAN. Okay, and the data is always stored on SAN, and it is not necessary that the both are used for the same SAN or same target. They cannot be, they're not necessary that they are on the same target. They can be at different target machines. They can be stored at different locations. Processor type, other options such as other ports such as USB port, such as NIC port or NICs or NICs. So NICs are always shared. NICs are always shared, again dedicated and shared both. Dedicated and shared both. You can, most of the cases it is always shared, but in some rare cases you can have dedicated, because we do not have multiple numbers of NICs in servers. We always have 4 to 10, at least 4 to 10 NICs are possible in one server or in one arrangement. So if I use dedicated, then I will not have enough for everyone. So in that case, because if I may be running hundreds of VMs, how can I use only 4 to 10 NICs for hundreds of VMs? So it's always shared. It's always shared. Every VM can have its own IP if they are running separate service, or even if they are running same service. Multiple VMs can be the part of one cluster network. Means there can be 10 VMs or 20 VMs running as one cluster in that server. So physically they have their own IP address, but virtually they will have just one IP address. This that we discussed before. This particular topic, that virtual IP address and physical IP address can be allocated to different services. So in a cluster, if I have 10 servers, then all the 10 servers can have their own IP addresses, but there will always be a virtual IP address which is allocated to the service, not to the one physical machine. So if you see the facebook.com, it's a service which is running on thousands of servers. So facebook.com has one IP address which has thousands of servers inside. All those 1,000 servers has their own IP addresses, but facebook.com has one IP address. Or these days we are using DNS, because we are not these days we are using DNS. So with the help of DNS, it is possible that one service can have multiple IP addresses. One service has multiple IP addresses. For US, we are using 5 IP addresses for US, 5 IP addresses for Europe, 5 for Asia Pacific, or let's say Asia Pacific has more users, so we have 10 IP addresses for. So what the DNS will do here, DNS receives the request, and based on the nearest server, it provides the IP address to that request. So this is your Facebook server. So if you are saying ping to www.facebook.com, so you may get one IP address now, if you go to California or if you go to some other country and you do ping facebook.com, you may get some other IP address there. There can be different IP addresses, but DNS can resolve or can hide. We never use IP address, guys. Remember, we always use name. What is the IP address behind it? We never know, because we never bother to care about that. And DNS is taking care of all that. Now, if you imagine the architecture here, then you are sitting here sending request to fb.com. It goes to your nearest DNS, whichever is nearest DNS. Let's say ISP DNS is your nearest DNS. So this DNS may have one IP address for facebook.com. So it will automatically or immediately gives you the IP address of that facebook.com, and then your browser will send the request to the IP address. This IP address is located in Atlanta. So facebook.com has a server located in Atlanta in some data center, and it provides the content to you. If that IP address, or let's say this DNS doesn't have the IP address of the Atlanta Facebook server, but it may have an IP address of Arizona Facebook server. So your request will go to the Arizona Facebook server, not to the Atlanta server, even you are sitting closer to Atlanta server. So it all depends on DNS, what IP address you are getting against your request. But for a particular session, you will always be connected to one server. It's not like that you are using you are doing a ping, or you are using facebook.com, and for one minute you are connected to Atlanta server, for second minute you are connected to Arizona server, for third minute you are connected to Singapore server. That's not gonna happen. So right now the IP address I am getting for facebook.com is 57.144.132.1. And why we are getting request timeout? Because these type of servers do not respond for ping. Period. They do not respond for ping. So using ping command on these servers will give you only request timeout. Why they do not respond for ping? Any cyber security student here? Cyber security major? Right? So you will study.
Is it to avoid DDoS?
DDoS. It is because of DDoS. What is DDoS?
Denial of service.
Distributed denial of service. It's a kind of attack.
Many requests come to that website.
Identity theft is not related to ping, but DDoS is, or DOS, just DOS, denial of service attack. So if your server is busy in responding the ping, and let's say 100,000 or 1 million users started pinging to the same server, the server is overwhelmed by sending the response to the ping command, it will choke and it will fail. So that's why these servers does not entertain your ping commands. But it gives you the IP address. If I try again, am I getting a different IP address? No, because this is the same connection. This is the same host. And even all of us are connected to the same ISP. Because of this internet, this network has the same internet connection. Isn't it? If your computer is connected via your mobile hotspot, or you go to home and do the ping on your computer to facebook.com, you may get a different IP address. So it all depends on many things. Many layers works in the background, and these are the basic things you are studying here. So let's stay with the basics. Now, VM network connection type. So every time VM has its own, or every VM has its own virtual NIC, because the computer is virtual, so the NIC of that computer will also be virtual. It cannot be physical. So that virtual NIC that can connect to the VM to the other machines that it operates at the data link layer. So function is exactly same. Just imagine, because there are a lot to imagine in IT industry. I'm telling you. Imagine the entire hardware. What you are looking here, this entire hardware is virtualized by the industry. There is nothing remains physical at all at the user level. At the user level, but somewhere some physical component exists. That's why the virtual is possible. Virtual cannot be possible in thin air. Correct? Your monitor is now virtual using Meta glasses or using Apple Vision Pro. Your screen is now virtual. You do not see the screen, but still you can see a big picture. Have you seen Vision Pro? Anyone? No? It's an amazing device. Apple Vision Pro. Right? I must say, you must go and take the demo of this device. Okay? Hello.
Excuse me. Do you have a camera extra black?
Which one is it?
Anyway, thank you so much. Sorry.
Okay. This is a device it's a VR headset, but it can give you a wide picture like you are sitting in a cinema hall. It can give you a picture, the view or the size of the screen. You can see that you are sitting in a cinema hall. Let me try to there was a video before. If I search for videos.
You don't have to come in knowing everything.
It was a marketing video of that page.
Apple Vision Pro is an unparalleled immersive experience. But marketing the device using traditional 2D advertising campaigns, it's impossible to replicate the magic of experiencing it firsthand. So we made 6 immersive films to literally demonstrate and market what is possible on the device itself, redefining entirely new boundaries of filmmaking and storytelling.
When you put on the Apple Vision Pro, it does change the way you think about creating a story. Because you're not watching a movie anymore, you're inside the story.
So what you actually viewing here, you will exactly experience the same. What I'm trying to say here is that everything is virtualized. Even the screen, your monitors, what you are looking here in front of you, is also virtualized. You can work on your Apple MacBook or Apple Pro while wearing this Vision Pro. And whatever you see on this small screen, you can see a huge picture in front of you because everything is virtual. Your screen is virtual. You can increase or decrease the size of your screen up to whatever size you want. You always feel like you are looking a wall-like screen. or a screen which you have seen in any movie theater. So, idea here is that we have virtualized everything, but in order to run that virtual thing, a physical hardware is required. You can't run anything out of thin air. What they are trying to do here is they are trying, we have particles in air, right? Everybody knows that we have some particle floating in the air which we can't see from our eyes. But now what they are doing, what the science people are doing, they are using those air particles as a screen. As of now, in order to do in order to project the picture, I need this physical screen. But now they are trying to use the air particles to project that picture for every individual. So everything is getting virtualized. But again, I'm repeating the same thing. In order to have that virtual thing, you need some physical device somewhere. And you are getting there to manage those physical devices. So in order to manage those physical devices, you must understand how those virtual things works. Okay, your name is Abel, right? Yes. Start with that. That's why we need a touch screen monitor so that we don't have that click 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 sound disturbing everyone. Okay, each VM can have several VNICs. A maximum number depends on the limit imposed by the hypervisor. So this hypervisor is completely a separate subject, separate course. VMware is running their own training programs. If any one of you is interested in making your career in VMware, you have quite a good height. Well, while you were sitting like a duck behind the monitor. I even can't see your face. So, VMware is a very, I would say, niche technology, and a lot of demand is there in the market for the VMware professionals. VMware has its own academy, and any one of you can do their online courses and can get the certification, and you can be a VMware expert. A lot of data centers and companies are looking for VMware experts or VMware professionals around the clock. So just search for the VMware related jobs. And not just VMware, Microsoft has its own virtualization technology which is known as Hyper-V, which is also in demand. But in my opinion, VMware has more market than Microsoft Hyper-V. Such as, if I look at the cloud, which cloud service provider is more popular in your view, if you know? AWS, Amazon Web Services. So you can be a cloud expert as well, cloud solution architect or cloud operator. Even just a cloud operator is good enough, or cloud solution provider or designer. You can architect. So there are various levels we have in cloud space as well. Okay, so when a VM NIC is selected, the hypervisor creates a connection. So it's all, see, everything is, even if I have hardware, everything is working based on software. Even a hardware can work because the software exists. So what the virtualization does, virtualization is presenting or mimicking this hardware with the help of some software and talking to the software. What is your software? OS. OS is your software talking to a NIC, and this NIC, instead of a hardware NIC, now I am using a virtual NIC. Instead of a hardware NIC, we are using virtual NIC. So if whatever operation my physical NIC was doing, we converted that physical NIC into a virtual NIC. We put something like robot. whatever robot human can do, now robot can mimic. So similarly here, whatever this NIC, hardware NIC can do, this virtual NIC can mimic. So this virtual NIC is now talking to your operating system. Operating system sees it as a NIC. Operating system will see it as a normal regular NIC, normal regular network interface card. It has its own IP address as well. You can also manage it. You can also do the firewall. Okay, same as with the routers and switches. You have seen those routers and switches in the back room. They have converted these routers and switches also into virtual routers and switches. So all these routers and switches are now can be used virtually. But what kind of hardware is required to run those routers and switches virtually? Do I need a physical routers and switches to run those virtual routers and switches? No. We just need hypervisor. We just need hypervisor or the servers where I can run those softwares which can mimic those physical routers and switches as a virtual routers and switches. So all the operations, whatever a physical thing can do, are now being done by a software. Even I have worked on virtual storage device, an entire storage device which is running on my computer. Can I use that as a real? No, I can't, because it was only for testing purpose, only meant for testing purpose, so that I can learn how a storage device can work. But if I put a real storage device behind that virtual storage device, so what is the benefit of that? The benefit is, just imagine, you have, this is virtual storage here, and this 10,000 users are connected to this virtual storage. They can be more than this. Every day I am adding 100 more users to this network. They are storing data. Behind this virtual storage, I can have n number of storage devices. I can keep on adding more and more storage devices no matter what, because my users are connected to this virtual storage. My user is never ever connected to any physical storage behind that. That is the benefit of virtualization. I can scale my physical network or physical infrastructure to any size, anywhere in the world, if I am having a virtual setup in front of that. This is the power of virtualization. By using VR headset, you can travel to Mars, or you can go to Pluto, or wherever in the universe. But are you physically there? No, you are not. But in this case, my user wants to store the data. Data needs a physical space. Data cannot store in the thin air. So this way I can create an environment which is running behind a virtual environment. So for the users, for the hundreds of users, this environment remains identical. This environment remains same. Now behind this, I may be using a Dell system, I may be using HP system, I may be using Pure system, I may be using any XYZ system behind this, no matter. My user remains unaffected for that. My user remains unaffected from whatever devices I'm using behind it. My user remains unaffected how old my devices are. My user remains unaffected if I'm replacing those devices in the background, because your user will never come to know what is happening behind this virtual environment. So virtualization is giving you a real power of scalability. Virtualization is giving you a real power of making your services available all the time, every time. And that's what data centers are coming up in future. Today also, but in the future also, you will see all these kind of setups in the data centers getting more and more popular. So VMware network connection. So what the VMware network or virtual machine network connection looks like? So in the virtual machine, you have couple of physical. So these are the only two physical networks or the NICs we have, which are now created as a 4-5 virtual NICs and allocated to every VM. Now these virtual NICs can be increased. So we can create more virtual NICs. So these are the virtual switch by the way. So we can increase the number of connections in these virtual switches up and down, because that all depends on us. We are creating these virtual NICs. We can decide how many connections we would like to create. Right now I have 4 VMs running here. Tomorrow I can have 10 more VMs added. Tomorrow we have only 2 VMs left in this server. It's all dynamically changing up and down, going up, going down. It decides based on whatever the service requirement is. So I can create those virtual environments. So as I can create these virtual switches here, which are connecting multiple virtual NICs together to the physical network. So now if you notice here, if one VM is trying to use this network, so this VM will end up using any of those 2 NICs. If all 4 are using the network at a time, then they are kind of sharing these 2 NICs. It depends how many NICs are there in your server. And they are using different modes. So one is called bridge mode, another one is called NAT mode. I will suggest you to go and read a little bit more about the bridge and NAT. Bridge means where the combined, where the NIC accesses the physical network using the host machine's NIC. So here the host machine NIC is this. These 2 are the host machine NICs. So obviously it will use it directly, means whatever the IP address of this VM is going through this virtual or this physical NIC. So any user sitting outside here can access this VM through this NIC directly, because this VM has an IP address which is accessible from outside. So that means the VMs may have an IP address which belongs to this entire network. So if I have a NIC which I can access within this network, so the VM has the IP address belongs to this network. If the VM is accessible, let's say the Facebook is running on that VM. The Facebook is running on that VM and I can access the Facebook. That means I am able to access the services of that VM through these 2 NICs. So that is possible only when you are using these NICs in the bridge mode. In the bridge mode. The other mode is NAT mode. In the NAT mode, these NICs are having some IP addresses which are accessible from rest of the network, whereas these VMs are having some private IP addresses which cannot go out from this network. So they remains within this device. Remains within this device, not going out. So this network address translation mode is working. So in that case, only the IP address of these 2 NICs can be accessible, but they may be running different services. So Facebook is running here, I can still access it, but only through or my request will come until this point. Beyond this point can be possible only because of the virtual NIC is working at this level. It is doing a translation of these IP addresses from private to public, public to private at the time of communication. Okay, so this is your another example of using. In some cases, you can use DHCP server also. DHCP server, I'm pretty sure now you know what is the role of DHCP server. Anybody remember? What is the role of
It
DHCP server?
automatically assigns IP addresses.
So it is assigned. It is used for assigning IP addresses to the requesting devices. And there is another type of connection which is called host only mode. So VMs on one host can exchange data with other within. So in this mode, the VMs can talk to each other. VMs can talk to each other, but not to the rest of the world. The internal communication is possible, but not outside. Some pros and cons of virtualization. So advantages are efficient use of resources. As I explained you, in the shared mode, if only one server is running in shared mode, then all the 36 CPUs can be used by one server. So better performance you can get if no other device is running. So I can utilize my resources completely. Cost and energy savings, fault and threat isolation, simple backups, recovery, replication. Now every point can have a very long discussion here. Efficient use of resources. I can, even if one of the virtual machine is running here, they still be using one of the NIC here. If one, even just one virtual machine is running. Okay, and if one virtual machine is running, then it can utilize the resources of this entire server. If I'm having four physical servers and three of them are not in use, then I'm kind of wasting my money in those three physical servers. Instead of using physical, so we are using virtual. Then I have cost and energy saving. Just imagine running four physical servers here versus running one physical server. How much cost and energy you are saving. So if you are looking for building a green data center, then virtualization is very much required in those type of data centers, because that way you can not only cost energy, but you can also save the cost of heat reduction, because every server is going to generate some kind of heat. When it is generating heat, then you have to use cooling to reduce that heat or remove the heat. When more heat is coming, then more cooling is required. Less heat is coming, less cooling is required. When less cooling is required, then you are wasting or spending less amount of energy to cool those equipments or cool the environment. So just see the cascading effect of all the things connected to each other. You are running four servers, more heat, more cooling, more energy required to cool the environment. Less server, less heat means less cooling means less energy is required to cool the atmosphere. And moreover, if you are upgrading your technology, then also you are wasting less amount of resources there. You are producing less wastage there. Fault and threat isolation. Your virtual machines are running, so virtual machines can be replaceable easily, because virtual machines are not physical. We can make a copy of this virtual machine and can start and stop anytime without much delay. Just imagine starting a virtual machine, the time required for starting a virtual machine and the time required starting a physical server. You can always ask this question to your let's co-pilot. You can ask these questions to these applications, right? The starting time of a virtual machine versus a where I was starting time of a VM versus real machine. This is taking hypervisor in consideration, but otherwise it is saying opposite of that. Because of it is considering that you have to start your hypervisor, virtual server and all that. But otherwise, if you are just starting a new virtual machine and a new physical machine, it takes very much lesser time than compared to a physical machine. It defies my theory. So, and even I can take the backup of those virtual machines. Can I take a backup of the physical machine? Not possible. I can take a backup of that virtual machine and can start simple backups, recovery and replication. I can produce duplicate virtual machines by just copying few files. Instead of, in order to create a duplicate server, I need a physical hardware exactly at some other location. Some disadvantages. Obviously, every advantage comes with, or every service comes with some disadvantages. Compromised performances. If I'm using dedicated mode of CPU allocation, then I'm limited to that number of CPUs on. I cannot go beyond that until I change it to the shared. Increased complexity. Your VMs, it says that your complexity will go up because you need to remember how many virtual machines are running on that server and where all the virtual machines are running for that particular service. Let me tell you one thing. Whenever you plan for a hardware, let's say you want to build a data center. You want to build a data center. So what should be there in your mind very first? It is always
Service.
what service you would like to run from that setup or from the infrastructure. What service you would like to run from that setup and how much data you are expecting. What service you would like to run and how much data you are expecting. These two terms should come first in your mind when you are thinking about setting up a data center. How much data and what service. After that, you will decide. So data decide how much storage is required, service decide how much computing is required. Computing will decide how many servers are required, how much network is required, how much security is required, and so on. So you keep on adding things to that. This should be your approach whenever you are designing something. And obviously single point of failure. Now single point of failure cannot be a disadvantage because you need to remove that. You have to work towards removing the single point of failure, and obviously increased licensing cost. Now these days vendors, service providers or software providers, software vendors, they have two types of licensing schemes. One, the physical license, or you want to run their application on one physical server, or the license for the virtual environment. How you would like to run the software application in a virtual environment. Okay, so based on that, you can buy the license, because in a virtual environment, it cannot never be a fixed usage of application. Right now, I have 15 students in the class, so 15 users are connected to the network. Tomorrow on the next class have 5 students only 5 users are connected to the network, only 5 applications are running. So there was a time when we used to have the license, we need to buy the license for the entire year. Now we are having a license pay as you go, or pay by user. Pay by user. Those many users, so if you are there 5 users, so I will pay the license for 5 users for 2 hours. 15 users, so I will pay the license for 15 users for 2 hours. So now the licensing entire system has changed actually. We are having a licensing, pay as you go. Instead of now, I don't need to download the softwares on my system. Microsoft 365. What is Microsoft 365?
That's like the office now.
That's the Office now. MS 365 is what we have MS Office years ago. We used to buy the subscription for the MS Office in order to use it on my machine. Do I still need to buy the subscription? Yes. But now we can use their application online and we only buy whatever I would like to use. Those heavy softwares like designing softwares or engineering softwares, those softwares are much more available or feasible for the end users because now we can buy them online and we can use them online as and when required and pay only for whatever amount of time we use it. So this is very long chapter here, a lot of discussion we have. Now this is the very important topic, SDN, software defined networking. In this, basically what we do is, or what we are doing, we are managing all our networking components or networking devices from one center location, and that is called NOC. What is NOC? No objection certificate. What is NOC for networking? NOC is a very popular word for networking. Network Operation Center. Network Operation Center. Now, have you seen? You must have seen multiple devices in the back room, right? We have multiple routers, switches, and all. So let's say I have multiple routers, 3 routers, and there are 2 switches each. So if I want to do any configuration on these routers and switches, remember that each router and switch has an operating system that is called iOS, Inter-Network Operating System, or just Network Operating System, NOS, NOC, NOS, Network Operating System or Inter-Network Operating System. Every device has an operating system. If I want to manage any of this, I can use my laptop and connect to this and do the configuration. Connect to this, do the configuration. Connect to this, do the configuration. Just imagine if you have thousands of these devices. Thousands of these devices you have and you want to manage all of these. Can you do that? Or how feasible it is? How feasible it is? So it becomes complicated. So what they did, they said that, okay, I will keep the configuration of all these devices at a central location or at a central server. So all the configuration from these devices are now here. In order to change the configuration of all these devices, I don't need all these connections. I just need a connection to this server. I need the connection to this server, and then from sitting here, I can change the configuration of any of this device. And then from this server, it will be implemented on all these devices automatically. It is like someone is controlling these devices through a remote connection. So I don't need to go to every individual device. It is now controlled by one location. That is your software defined networking, where everything is now controlled. So this unit becomes so important for us, where everything is now controlled by here, by this server. And this server can be duplicated, can be protected, can be firewalled, and so many things can be done. So it is like a central server for your entire network or a large size network. And this is there is another term we are using here that is called infrastructure code or infrastructure as a code. Have I talked about that in this class? Infrastructure as a infrastructure as a code. This is a very important term popular these days, infrastructure as a code. And this is a way to manage large scale infrastructure environments which has multiple servers, multiple devices, multiple networking components. So infrastructure as a code, or IAC, is the practice of managing and provisioning computing infrastructure including networks, virtual machines, load balancers, using machine readable definitions. So whatever you would like to do on your devices, on your servers, that you can do by writing codes. Like you want to do software update, you can do by writing some code. You want to change the firewall setting on 1000 firewall servers. There are 1000 firewall servers and you need to change the firewall settings on all the servers. You can write a code, execute it on all 1000 devices and everything changed. You remember something, Cloudflare? There was Cloudflare or it was someone else?
So what, the Cloudflare outage?
Outage.
Yeah, I remember that. When all the flights were down and all that stuff.
Yeah, that's right. So what happened there? They updated their servers by using something like this, and all the servers got updated by some wrong information, and everything went down. Everything went down. So this is sometimes can be fatal also. It's not that. So it has to be checked thoroughly before you execute any such operation. So what I'm trying to say here is that when you know something, few things, then there are another things associated with that. So read more about this software defined networking in this lesson. Then cloud architecture we will discuss next week. Okay? We will discuss about the cloud architecture. It's a very nice topic, and some of you are already using cloud in many ways. For example, your Blackboard. Your entire Blackboard service is a cloud-based application. Now you may say that, no, it is an internet-based application. Simply say that it is an internet-based application because you can access your Blackboard through internet. What is cloud? What is cloud in it? So this is running on a cloud infrastructure. Blackboard is running on some cloud infrastructure. Now, because cloud can provide you many things such as here, infrastructure as a service, platform as a service, software as a service, anything as a service. So depending on what type of app, what is your use, what is the use of your cloud? So that's why I'm saying that this cloud, this Blackboard is running as service on one cloud platform. Alright, so let's talk about it next week. That's all for today.